of the building. Okay, the height of the penny over time can be represented by the equation negative 16p squared plus 400. All right, so to graph this, what do we have to take? Yeah, we're not going to use the stat button like we did yesterday. Yeah, we got the y equals. What are your y equals? Okay, and we're going to plug that in. We're going to pretend that t is an x. So negative 16 x squared plus 400. Okay, and then we're going to get graph. Does it look like the picture? All right. Yes? Okay, so that is when it's set at a standard window. That's what it's going to look like. Okay? So now they want you to hit window. Okay, they're looking at number 2 right now. We're hitting window. And it says change the Y max. We're going to go down here to where it says Y max. And we're changing it to 400. Okay, and then we're going to look at our graph again. So they graph. Okay, and it asks you, why is this view more useful? Huh? You can see what? You can see the vertex, so you can see all the key parts of your parabola. There you go. So that's your number 2. You can see all the key parts of your parabola. All right. Now, if you remember our x's, so our x's are this guy's down here, right? And they represent who? Well, x's represent what? Time. Okay? So 3 asks us, why might it not make sense to show the negative x's? So, yeah, we can't have negative time, can we? Okay, you can't have negative 4 seconds. Okay, so there you go. Can't have negative time. Okay, so because we can't have negative time, we are going to change our x min to 0. So go back to window. Ooh, that's not window. That's not window. That is. Okay, and where it says x min, they want that to be 0. Okay, now if we, okay, so we're going to hit graph. It does look like that. Wait, does it look like that? Okay. So they want you to label the top of the building with a B. Okay, remember you're throwing this penny off the top of the building. Where's your B at? Put it on your graph. Label your graph with a B. Where are you throwing this penny off the building? Yeah, it's going to be right here, right? Not even the highest point, where x is 0, right? Because that's where I'm tossing my penny off the building. Okay? And it says it wants an x where the penny hits the ground. Okay, hopefully nobody said in here. Somebody said, I heard, that if you throw a penny off the Empire State Building, you can actually kill somebody. That's a myth? What? How does it lose value? What? Yeah. That doesn't even make sense. do some tracing, right? Okay, so that means we gotta retrace. Okay, when the penny hits the ground, what will be 0? The x or the y? The y is going to be 0 when that penny hits the ground. So how many seconds did it take for it to hit the ground? 5 seconds. Yep. Okay, then it says how far off the ground was the penny at 0 seconds. So what do I have to go to what is 0? 0 seconds, yep, would be where x is 0. So x is 0 at how many feet? 400. Which makes sense because we were standing on top of a 400-foot building at 0 seconds, right? Okay, so how far off the ground was the penny at 2 seconds? We got to find where x is 2. And it's about what? 330. Not 330. 333 is down below 2.02. Yeah, maybe 330 or 335, 336, somewhere in there. What am I labeling my answer as? Feet on this one, yep, because it's how far off the ground was it? Okay, so now it wants to know how many seconds did it take the penny to fall 200 feet. So am I looking for x is 200 or y is 200? Looking for where y is 200, so go ahead and do that. And then do your 300. You guys do those two. Find your 200, find your 300, yes sir? Why are you hitting Zoom 6? Where? Yeah, way back in number 1, but then we changed everything. Like we went step by step to get everything into our normal window. To get to the window that we wanted. We don't want to hit Zoom 6 anymore. Because so go back and change it to where it said change your y max and where it changed your x min, and then leave that window. Don't go back to Zoom 6. You don't want Zoom 6 in these. Okay, that was the whole point. Is Zoom 6 is okay, we have a new equation. It's hard for you guys to see yours on yours because your page numbers went over the top. Okay, so go back to your y equals. Now it's negative 16t squared plus 64t. Okay, a graph. Okay, and now it's just this little blob, right? Does it look like the picture? Not really, right? So what we're going to do is we're going to edit our window again. Okay, so it says the height in feet of a golf ball hit into the air. Right? And what we're going to play around with is our x max and our y max. It's telling us right here, right? Okay, so if you hit a window, okay, if you look at your picture, how many dashes does it have for my x's? 5. So let's change our, we want that to be 0. Let's change our x max to 5. So that's how many are in the picture. Okay, and then if you look at your y max, how high do you think you can hit a golf ball? Huh? Well, you can hit it pretty high, but on a normal drive, how high do you think it might go? Let's just use some common sense. Huh? Looking at your equation up there, okay, so these are kind of some of the numbers that you're dealing with. What might be a good number to put as far as my y max goes? Okay, but I'm asking what number, because we have to change our window. What number do you want to change your window to? Huh? 70 might be a good one? Okay, so I try to go like, even like integrals. So 70, what else? Well, okay, so let's think like it. So we're thinking like 25, I like 75, I like, if we're going up by like 50s, or going up by like, what would be an even number? Like if I'm dealing out money to you, oh my God, how about 100? Right? 100 would be a nice even number, right? Not really. Okay, but here's the deal, 64, it's going to go a little bit higher than 64. And since we don't want, okay, because it's going to be hard to see, listen, okay, if I pick 64 and it only goes 64 feet high, just listen. Okay, don't play around with your calculator right now. Okay, that means my vertex is going to be way up here, right? Do I necessarily want it in my entire screen? No, I want some room to be able to see it. Okay? That's why I chose 100 on it. Okay? Now, for part A, the maximum height, I want to show you how to find max without using the trace button. I want to show you how to find the exact maximum without having to estimate it. Okay? So, we're going to calculate something. So, we're going to hit second, trace. Because that calc is above trace. And what are we calculating? The maximum, right? So we're going to hit 4. Okay, now, down here, it's asking for left bound. Okay, and what that means is I have to move my cursor to the left side of my vertex. So I want to go a little bit past my vertex to the left side of it. Okay, hit enter. And now what is it asking for? The right bound. So I'm going to move my cursor so that I'm on the right side of it. And hit enter. And then what is it asking for? Yes, so now I'm going to move my cursor to close to the middle, or close to my vertex as I can get it, and hit enter again. Okay, and now this is your exact height. So what is my maximum height? 64 feet. Okay, so let's talk about this. So our maximum height is 64 feet. What does that 2 stand for? That's the time that it took to get to the maximum height. So is that our, how long does it take to get to the maximum height? It was what? 2 seconds. Good. Because it tells us number of seconds elapsed. Okay, so usually in your problem it'll tell you what you're doing. Okay, now it wants to know how long it takes to hit the ground, right? Okay, so let's use our trace button. Get it over to hit the ground. Okay, you guys write that one in. Okay, and then in D it says, for how many seconds is the ball more than 48 feet in the air? Okay, so we're still on trace, and let's scroll to where it's above 48 feet. At what point does it get above 48 feet? How many seconds? So let's call it 3 seconds. Okay, but come on, that's not our whole answer. Okay, and then if I'm going back, because okay, so 48 is about right here, and it's going to be over here, right? So at what point does it go below 48 as I'm going backwards? Do this on your calculator. At about 1 second. So how long does it stay above 48 feet? About 2 seconds, yeah. Okay, so some of these problems are going to make you think a little bit. You're not going to be able to just pick out your answer, right? All right, so now we have on the top of the hill, a rocket is launched upwards from a distance of 80 feet above the lake. Okay, the rocket will fall into the lake after its engine burns out. The rocket's height in feet above the surface of the lake is given by the equation where t is time in seconds. So we've got to go to our y equals, put in our new equation. How come I keep seeing this negative 16? What's this, like almost every problem that we've had has been negative 16 in front of my t squared. Anybody know what that symbolizes? It has to do with the parabola, yeah, and the fact that it opens down. But think about all of our problems are like being thrown off a building, right? They're all coming down. What makes something come down? Gravity. Okay, that negative 16 deals with the pull of gravity. So a lot of the problems that you see with parabolas and coming down are going to have that negative 16 in real world because that deals with the pull of gravity. But we're not dealing with seconds. We're talking about the equation of a parabola. Okay, so it's totally, you're thinking of something completely different. Okay, so now we want to edit the window. So we got to go back to the window. How many dash marks do you see? Okay, so what should we change our x max to? Or if we want it nice and even, it might be. Oh my goodness! 10! Sheesh! You're killing me! Okay, think of it as like, what would you want to count by? Do you want to count by 12s or 10s? I want to see you count by 12. All right, then. All right, and then we got to go down to our y max. Okay, well, so launches from a distance of 80 feet above the lake. Should we try 100 and see what it looks like? Yeah. All right, so let's graph it. Ooh. So it doesn't quite fit, right? Okay, so go back to your window because this kind of becomes a mess and check. Okay, we're at 100 right now. What do you want to change it to? Oh my God. Okay, so let's try 150. Does it fit? All right, so draw it into your box. They want you to draw it. That's number one, is sketch the graph in the space. So I would sketch about where it hits 1, 2, 3, 4, 5, and then just kind of make it look like this. Okay, notice how it doesn't go all the way down to the ground over here. It kind of starts up here. Huh. Okay, so go back to your y equals. Figure out what you did wrong. Go to your window. What did you change? Okay, well your x max. Okay, so your y min can't be bigger than your x, or your x min can't be bigger than your x max. For x min, what do we keep our x min at? What is this my minimum x? 0. My max is headed to change to something else. Oh, good. Thank you. All right. It wants an A at the spot that represents the top of the hill. Now, is the top of the hill my parabola? The top of my parabola. Really? Okay, so read the problem. It says, on the top of the hill, a rocket is launched upwards. So think about where the top of your hill is. Okay, they want an A at the top of your hill. pocket starts to fall. So as it starts to go downwards is where they want their B. Okay, I will tell you this, your A and your B should not be the same spot. You might have to rethink your A. Okay, and your C is that splashdown. Okay, and then you guys are going to do A, B, and C. One. Okay, so go to your Y equals. Okay, because it looks exactly the same. Okay, so then go to your window. What did we change our X max to? Okay. Okay, you tell me that. Okay, how long does it travel upwards? So if I ask you how long did you travel, okay? You should dig on your A and your B and your C. Use your trace button or calculate your max. Okay, so your next one, we've got some archery going on. Okay, when an arrow is shot into the air, I'm not really sure why we're shooting it up into the air. Okay, its height in feet above the ground is given by the equation. Okay, so I'm going to graph this guy. Does it fit with what we have? Yeah, it's pretty decent. So go ahead and sketch your graph. Alright, so number 2, it says the plus 5 at the end of the equation means the arrow started out at 5 feet above the ground before it was shot in the air. Why? Good. Yeah, and that person might not be 5 feet tall, right? Because I'm not 5 feet tall, but I might be shooting from 5 feet, right? Why? It doesn't, yeah, I'm not shooting up above my head, right? I'm shooting right here, so it means that that arrow was 5 feet high. Okay, where it was shot. Alright, go ahead, maximum height. How long does it take for the arrow to start coming back down? Where it hits the ground. Okay, and then D says suppose the arrow hits a tree after 1.5 seconds, stopping its path. Okay, how far up the tree would the arrow hit? So where, what are you looking for? You're looking for where? You're looking for at your X or your Y there? You're looking at where your X is what? 1.5, yep. And looking for how high up that is. Anyone played with your graph on this one? Yet? Chris, have you played with your graph on this one? On the softball player? What did you put for your Y max? Oh, but you already have your sketch drawn. How is that possible? Yeah, how do you have your sketch drawn already if you just started it? Oh. Okay, so if we plug that in there, play with your window. Okay, and I'll tell you this, the only thing that you really have to play with is your Y max. Okay, think of a school pitch softball player. So you're taking the softball, you're lobbing it to the batter, Think about how high it might go. Okay, if your Y max is at 100 or 150 now, that's not going to work. Okay, your graph should look similar to this. Look up here. Your graph should look similar to this. If it's just a little hump right here, you need to change your window. Okay, if you just have this little hump, your Y max needs to come down. Okay, so if you, first of all, if it looks like that, you did something wrong. Okay, so if you graphed this and you didn't change your Y max, it's going to look like this, and I'm going to mark it wrong. Okay, so you got to go into your window and you got to play with your Y max. And this is a guess and check deal. You do it. I'm not going to tell you what to do. I'm not sure why mine is coming up like that. Okay, you can probably look a little bit like that. You got to play with it. What did I just say that you're supposed to change? That's the only thing that you have to change. And the only thing you have to change right now is that. How are you going to find where the ball is released from the pitcher's hand? Where it starts, yep. Where'd you get for where it started? 3 feet, yep, okay, because you got to think the pitcher right here, probably about 3 feet when I release it from my hand. So if the batter hits the ball at the same height, where are you looking for?